Hey, Chris here from LlamAcademy, here to help you, yes you, make your game dev dreams become a reality. Today is part 6 of the AI series where we're adding attacking to our NavMeshAgents, and this one's really exciting because this is the full life cycle now that we have for the enemy. They can spawn, they can follow the player, they can attack the player, and they can be disabled when they run out of life. The player will have the same thing, they can run around. They come pre-spawned, but they can run around. They can attack the enemies, and they can also be disabled, which will end the game whenever they run out of life. So this is a pretty cool one. We've got the full you can make a game out of this once we have this together. So I'm really excited to bring this to you. We're going to implement this with an attack collider. So we're going to put a collider in front of the enemy and in front of the player. Whenever they enter each other, they'll start punching. And each punch does some amount of damage that we will configure in the EnemyScriptableObject. So we won't just be configuring the NavMeshAgent anymore in the EnemyScriptableObject. We're going to configure how much damage they do, how fast they attack, and how big that collider is going to be. I'm excited, so let's jump in and check it out.
First thing I want to highlight is there are some new animations in this repository. These came from Quaternius. This guy released I don't know if it's a guy, this person released this model and some animations attached to it that we're going to use the animation part on our UniChan model so that way they will punch each other. I needed some kind of animations I could freely distribute. These are available under their Creative Commons license. So the license is in this repo. If you want to take a look, that person should get the credit for these. I did not make these animations. I'm not an animator. I don't really know how to do that. We're going to do a little bit of script folder refactoring. So we're going to kind of group stuff together because we are getting out of hand with having all the scripts together. We've already done this with the object pool and the enemy. We're going to do that with the player now. So I'm going to create a new folder called player. In there, I'm going to create a new script called player. I'm going to drag the player movement from the root level scripts into that folder. And I'm going to create a new script called PlayerCameraController. Then in the root level scripts, we're going to create a new script called IDamageable and a new one called AttackRadius. Let's open the IDamageable script and we'll change this to a public interface IDamageable instead of a class that extends mono behavior. We're going to make any class that can be damageable implement this interface. So add a void take damage, which will receive an int damage, and put a semicolon at the end there. Since this is an interface, we don't define the implementation of what happens when we take damage. We just define that if you implement this interface, you must implement the functions that we defined here. We'll also add transform get transform. So we're saying that anything that's damageable should be able to tell me what their transform is and should have a way to take damage. Let's open the AttackRadius class. At the top, let's put require component type of collider because we're going to use the OnTriggerEnter function. So we'll put a private list of IDamageable and make that called damageables and make that equal to a new list of IDamageables. We want to maintain a list of damageables that are within my attack radius, and we're going to attack the closest one. We'll put a public int damage and assign that to something like 10 by default. The default doesn't really matter. We're going to override that later. Public float attack delay. This will be the delay between each time that we do this damage. And I'll add a public delegate void attack event, which takes an IDamageable target. This is so whoever has the attack radius can receive a callback of whenever we're going to start attacking. And we'll do that with public attack event on attack. Then I'll make a private coroutine attack coroutine so we can manage running of the attack coroutine. We'll implement the OnTriggerEnter magic unity function that takes a collider, and we'll call that other. This function is called whenever another object that has a rigid body component enters my trigger collider. So whatever collider we attach this to, we need to mark in the inspector the isTrigger checkbox. In here, we'll do IDamageable equals other.getComponent IDamageable. So this is something cool that getComponent doesn't work only on mono behaviors, it works on also interfaces. So we can receive, if this other component has a damageable, meaning it's not null, we'll add that damageable to our list of damageables inside of this attack radius. And if our coroutine for attacking is null, then we'll start the coroutine attack. We'll then implement the inverse of OnTriggerEnter called OnTriggerExit and do almost the exact same thing. We'll get the damageable from the other collider. If it's not null, we will remove that from our list of damageables. And then we'll check if our damageable count is 0. If it is, we'll stop attacking and set the attack coroutine to null. Now let's implement the attack coroutine. That's private IEnumerator attack. We'll create a new wait for seconds, wait equals new wait for seconds attack delay. Then we'll yield return wait, so as soon as something comes in we don't immediately attack, we should always wait at least the attack delay. And then we'll set the closest damageable to null, and we'll also get the closest distance and set that to the max value of float. Then we'll check while damageable count is greater than 0. We will go through each of those damageables with this for loop, and the goal is to find which damageable is closest. We're going to attack whoever's closest to us first. You can of course implement this any way that makes sense for your game. You could make it so they attack whoever came in first only and stay attacking that one until they're dead and then pick the next one. The implementation of this can be however it makes sense for your game. We're just going to do whoever's closest, we're going to attack that one because our person thinks that's the biggest threat. So we do that by doing damageables indexed by i.getTransform. Then we calculate the distance using vector3.distance, transform.position, and damageable transform.position. We check if the distance is less than the closest distance. If it is, then we assign that closest distance to be this distance and our closest damageable to be this damageable. After we've iterated through all of our damageables in this attack radius, we will check if the closest damageable is not null and invoke that onAttack delegate void that we made with the closest damageable. We'll also say closest damageable.take damage with the damage that our attack radius says that we do. We'll then unassign closest damageable and closest distance by resetting them to what we said at the beginning. We'll yield return wait. Then we'll remove all the damageables that are disabled using damageables.remove all disabled damageables. We'll do this because after we kill an enemy, that game object becomes disabled because they're pooled objects, remember? From the 4th video in the series, we used an object pool for these, so they become disabled instead of just disappearing. We need to go through all of the damageables and remove all of the ones that have been disabled, not just the one that we attacked, because potentially something else disabled it. So I'm going to add this disabled damageables private bool that takes an IDamageable, and we'll just check that the damageable is not null and the game object is not active. Because if the damageable is null, we'll get a null reference exception whenever we try to get the transform, so we don't want it to be null. If it's not active, then that means we've disabled it somewhere, and we don't want to try to attack that one anymore. Next, let's open the player class. We'll add a private attack radius, and we'll serialize that field so we can assign it in the inspector. We'll do the same for our private animator. I'll add the private coroutine look coroutine so we can manage facing the enemy that we're going to attack. I'll add a private int health, set that to 300 by default, and I'll serialize that so I can modify it in the inspector. On awake, I'll do AttackRadius.onAttack plus equals onAttack. So we'll make then that private function called onAttack. This again needs to match the delegate function signature, which is void return value IDamageable as the parameter. In there, we'll do animator.setTrigger attack trigger, and I'll add a private const string attack trigger called attack. This is going to be the exact same string that we use on the animator component as a trigger. We'll check if the look coroutine is not null. We'll stop it if it's not, and then we will assign it to the return value of start coroutine look at target.getTransform. This is the exact same thing that I did in this other video, the smooth look at video. There's a card on the screen and a link in the description for that video. I'm going to gloss over kind of the finer details and all the explanations that I normally do for this because I did a whole video dedicated just to make a transform smoothly rotate to look at another transform. If you want more details on it, check out that video. So in this look at function, we're going to take the look rotation from quaternion.lookRotation target position minus transform.position. We'll set float time equals 0 and while time is less than 1. We will assign the transform.rotation to the return value of quaternion.slurp spherical lerp, where we pass in the current transform.rotation, the look rotation that we calculated at the beginning of the coroutine, and the time. Then we will increment time by time.deltaTime times 2, and that's just to speed it up. Then we yield return null to wait for the next frame. And at the end, we assign transform.rotation to the look rotation that we calculated at the very beginning. Then we need to implement that interface IDamageable. We'll implement public void take damage int damage, and in that we'll do health minus equals damage, so we're subtracting whatever damage came in from our health. We'll check if health went below or is equal to 0, and if it is, we'll disable this game object. This is under the assumption that the player script is attached to the root level player object. So if your player is set up differently, you will want some different disabling logic. Public transform get transform will just return the transform. Next, let's open up the enemy class. We'll make that also implement the IDamageable interface. On take damage, we're going to do the exact same thing, health minus equal damage. If health is less than or equal to 0, we will disable this game object. This take damage comes with the same assumption that enemy is attached to the root level enemy game object. We'll do the same thing in get transform, where we'll just return transform. And we've already assigned the health to the EnemyScriptableObject.health on enable. So anytime that this enemy spawns or is recycled, their health will be reset. Since our enemy and our player are very similar in their behaviors, I'm going to copy paste everything we just did on player with the attack trigger, the onAttack assigning, the onAttack function, and the lookAt coroutine. I'm going to paste that into the enemy script. Then I'll come in and create the class member variables that we need. That's the AttackRadius and the animator. I'll also create the private coroutine look coroutine and the private constring attack trigger. So that way we have all of those references available in those functions we just copy pasted. Now we've set up the enemy with an attack radius. We need to update the EnemyScriptableObject to configure that attack radius. So remember in the previous videos, we configured this EnemyScriptableObject that mostly just configured the NavMeshAgent, and we added this health that was this mysterious value that didn't do anything. So now we're using that health, and there's three things that we can add to the EnemyScriptableObject. There's the attack delay, the damage, and the attack radius. So depending on how we configure these scriptable objects, we will automatically update these values of the attack radius. So we'll add public float attack delay, public int damage, and public float attack radius. But remember that we made the attack radius only require a component of collider, and not all colliders have a radius. So I'm actually going to come in here and change that to be a type of sphere collider. And then I'm going to add a public sphere collider reference into the attack radius. And I'm going to assign that on awake by doing private void awake collider equals get component sphere collider. Now let's use these values from the EnemyScriptableObject on the enemy. In the public virtual void setup agent from configuration on the enemy class, we will do AttackRadius.collider.radius equals EnemyScriptableObject.AttackRadius. AttackRadius.AttackDelay equals EnemyScriptableObject.AttackDelay, and AttackRadius.damage equals EnemyScriptableObject.damage. The last script that we're going to do is the PlayerCameraController. Before we had the camera just kind of zoomed out and you could see the entire level. That was cool whenever we needed to see the entire level and allow us to click all over the place to show the NavMesh links and stuff like that. Now it doesn't make as much sense. It's a very large level and it's actually really hard to see a lot of the stuff that's going on. So it'd be better if we had a camera that followed our player. So we're going to do that really simply with this class. We're going to add three private serialized fields, a game object called follow target, a camera, which is a reference to the camera, and a vector3 offset, which will be the offset from the follow target. Then on update, we're going to do camera.transform.position equals follow target.transform.position plus the offset. And then in the inspector, we'll just assign the offset to be a high Y value. We can also include the X and the Z if we want to be a little bit more at an angle. If we hop back to the Unity editor, let's start setting up the scene for the demo. I'll add a sphere as a child to the player object. I'll remove the mesh render and mesh filter, set the sphere collider to have isTrigger to be true, set the radius to 2, and attach the attack radius script to this object. I'll then select the player, attach the player script, and drag the attack radius to the attack radius object reference of player, drag the animator to the animator reference, and we'll leave health alone. If we then open the animator, we'll add an attack trigger as a parameter and name it attack. It should be the same as what we named the attack trigger in the player and enemy class. That's capital ATTACK. And then let's add a new layer. We'll call it attack layer. And we'll drag the human armature punch from Quaternius. We'll make the default state be nothing and have any state go to human armature punch and make it do that when the attack trigger happens. This is a humanoid animation type. It should work out of the box. If we go back to the animation panel, in previous animation, we can see that it looks like it works. Then we'll select the attack layer, change the weight to be 1. That way it will override whatever's happening, but we're actually going to do blending of additive. And then we need an avatar mask. So I'll go to the animations folder and create avatar mask. And we'll call it upper body mask. From here, we will deselect the floor, the inverse kinematics, and the legs. I renamed it to arm mask, but we'll rename it back to upper body mask. I messed up on this part. And we'll assign that to be the avatar mask of the attack layer. Now let's open the basic enemy. There we'll do the same thing where we create a sphere, remove the mesh renderer, mesh filter. I'll set the radius to something like 1.5, set it to be a trigger, and add the attack radius script to this object. Then on the basic enemy, we'll drag the animator and the attack radius to the script references there. I'm going to create 4 new layers: player, player attack radius, enemy, and enemy attack radius. This is an important optimization for 2 reasons. 1, every time that we have any collider with a rigid body enter the attack radiuses, it will trigger that OnTriggerEnter event and OnTriggerExit event whenever they leave. We don't want objects that we're not going to interact with to trigger that function. There's an associated performance cost with calling these functions and doing the physics processing to call those functions. We also want separate attack radiuses for the player and the enemy, so we don't have enemies triggering the OnTriggerEnter and having enemies attack each other. Now I'll go to the project settings, physics. I'm going to update the collision matrix. We're going to make it so the player attack radius only collides with enemy and the enemy attack radius only attacks with player. If you have other objects that should be attackable by both of these, maybe you put those on a new layer. I've also disabled collisions with the player and enemy with all other layers. Right now this isn't necessary and I may have to go back later and re-add some depending on some gameplay mechanics we'll add. Now I'll change the player to the layer of player, and I will not change all of the child objects. I only want the root player object to be on the player layer because that has my collider and my rigid body. I'll change the attack radius for the player to player attack radius, and I'll do the same thing on the enemies. I'll change the basic enemy, the root level object, to be on the enemy layer because that has my collider and my rigid body, and I'll change the enemy attack radius to be on the enemy attack radius layer. Let's hop back to the player, and I'll attach to the root player object the PlayerCameraController script. I'll drag the follow target to the model, I'll drag the camera to the camera reference, and I'll set the offset to be 0x8y0z. This will make the camera follow the player 8 units above it. And then if I click play, we can see that the enemy comes up to me and my player immediately starts turning to look at them and then punches. We can also see that enemy, when they get a little bit closer, starts looking at me and attacking as well. As my player runs away, while she is still attacking, she's looking at the enemies and running forward. Once the enemies leave the attack radius, she starts turning to face the direction that she's actually going. We can also see if I select the player that every time I'm hit, I'm losing some life. The enemies we can tell because they're getting disabled after a few hits that they are correctly taking that damage. Now I've killed all the enemies, let's take a look at this animation because you may have noticed while the enemies and the player rotate to look at each other, it actually looks like they've turned too far and are punching off to the side. If we quickly look at this animation, the full animation has the legs of the humanoid turn some and then punch forward, and since we've avatar masked out the legs, the player and the enemies don't get that turning motion that happens in this animation. So that's why we're punching kind of off to the side. If I preview the animation just on the animation panel, we can see that the Unichannel model correctly does this turn and will punch straight forward. So that is something to keep in mind whenever you're using animations on your models. You need to make sure that the ones that you got, if you didn't make them all yourself, do accurately represent what it is you're trying to do. Or you might have to get more clever with your avatar masking and blending of animations.
I hope you got a lot of value out of today's video. Being able to add attacking and dying into your game makes it so we've completed the circle. We have everything you need to get started making your own game with AI. We've got the NavMeshAgent spawning. We have the following. We have the attacking. We have the dying. We have the player movement. We have the player attacking, and we have the player dying. So that's everything you need to get started making your own game with AI. But don't worry, there's a lot more to cover, and I'm going to be covering a lot more topics on the AI series. Because this is the basic level implementation, right? If you release something with just this level stuff, it's not going to look super great. It's going to feel unpolished. So we're going to go into more deep topics, maybe having animation blend trees on our NavMeshAgents, maybe having more different enemy types, maybe having abilities for your enemies to use. I haven't fleshed out all of the future of the AI series yet because there's still so many things that can be covered, but I'm going to cover a lot more stuff before the end of the AI series. So come back, next week, next Tutorial Tuesday, and I'll have something more for you. If you have any questions, if you have a suggestion for a topic, or if you're implementing AI into your game as a result of watching this series, drop a comment down below, and I'll see you on the next video.